Today's lesson expands on what we discussed on Monday about elements. Today, instead of talking about what elements are, we're going to talk about how they're organized, specifically how elements have been organized over time onto the periodic table. There are a number of objectives that go along with this section. Describe how Mendeleev arranged elements on the very first periodic table. Also explain how elements are arranged on today's periodic table. Compare the three main groups of elements, metals, nonmetals, and metalloids, based on their properties and their location on the periodic table, and be able to describe the difference between a period and a group. So the most important man when it comes to the discovery of the periodic table is a Russian chemist named Dmitry Mendeleev. There's a video at the end of this lesson that I'm going to ask you to watch that will tell you a little bit more about this man's very interesting life. But he was the first person, or is attributed with being the first person, to discover patterns in all of the known elements around 1869. He organized these elements based on common properties, and this is really important because understanding the relationship between the properties of elements helps scientists to understand how those elements interact and react with one another. Mendeleev came to his discovery by doing a card sorting activity. He created cards for all of the known elements in the world, and he sorted them. He picked characteristics about them on each card, and he sorted them in a variety of ways. He sorted them by density, he sorted them by melting point, he sorted them by appearance. And what he found is when he sorted them by atomic mass, by the amount that each element weighed, he started to see some patterns. He discovered that when these elements were arranged by atomic mass, similar properties occurred at regular intervals. And we call this idea that things are going to repeat at regular intervals being periodic. There are lots of periodic things in the world. We think about days of the week being periodic, right? You start with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then return back or repeat back to Monday. The seasons are the same way. We go through all 4 seasons and then boom, we're back at winter again. There are lots of other things that are periodic too. I'm sure you can think of other examples of cycles that are periodic off of the top of your head. Mendeleev noticed that these properties that he saw in elements, when he organized them by atomic mass, repeated every 7. Today, if you look at the periodic table, you'll notice that those elements actually repeat every 8 intervals. The reason why Mendeleev thought it was repeated patterns after every 7, and we now know it's 8, is because back in the late 1800s, scientists did not know about noble gases, which is our last group of elements. They don't react with anything else because they have a complete layer or level of electrons in their outermost level. We'll talk more about that later, but basically scientists didn't know they existed, and so Mendeleev saw these repeating patterns happening every 7 elements. This table, once he had discovered it, became known as the periodic table of the elements, and there you see our vocab word in the title, periodic. That refers, of course, to the fact that these elements repeat patterns. Mendeleev was able to use these patterns that he observed to predict the properties of elements that hadn't even been discovered yet. And by 1886, all of the gaps in the table had been filled, and Mendeleev's predictions were all found to be correct. So now we know a great deal already in the late 1800s about matter, about elements. Back in that time, there were some elements that didn't exactly fit into Mendeleev's pattern. Mendeleev was so confident that he was right, though, that he thought this was actually because the elements hadn't been properly discovered and documented. He didn't think it was him. He thought it was the science behind what they knew about those elements, and he actually was right about that. New atomic mass measurements showed that his data was right, and the original data for those elements was wrong. There were other contributions, of course, to this study of elements and how they're organized as well. Henry Moseley, for instance, determined that the number of protons inside of an atom, which is also called the atom's atomic number today, was actually a better way to showcase this pattern that Mendeleev had found. Mendeleev had been studying the mass, so the overall amount of matter that made up each element. The number of protons, however, actually categorized these groups, these characteristics that Mendeleev had seen more reliably, and thus led to the periodic law. which is a law that states that the repeating pattern of chemical and physical properties of elements changes periodically, so in intervals, repeating patterns with the atomic numbers of elements, the number of proteins. Elements are classified by these properties into 3 categories, and we did talk about these categories on Monday too. They're metals, nonmetals, and metalloids. The number of electrons in the outermost layer of an atom is going to determine which category of those 3 an element belongs in. There's going to be, if you look at a periodic table closely, a zigzag line that runs through on sort of the right-hand side. And that line helps to show where one group of elements starts and where the next one stops. Most metals, for instance, are going to be found to the left of that zigzag line. There are all of these teal or blue-colored squares on the picture. All metals have a number of characteristics in common. For one thing, they have few electrons in their outer energy level. So their outermost level of electrons, if you think back to Niels Bohr's model from our discussion about atomic theory, doesn't have as many electrons in it as it could. Metals are solid at room temperature, they're shiny or they have a metallic luster, if you think back to conversations about minerals. They're ductile, which means that they can be drawn into thin wires. They're also good conductors of electric current. Conveniently, that means we can use wires for electricity. They're malleable, so in addition to being able to be drawn into wires, they can also be flattened out and reshaped with a hammer. And in addition to being good conductors of electricity, they're also good conductors of thermal electricity. So they are going to conduct heat really well. This is why we use metals for pots and pans, because we can put them on the stove top and that heat is going to conduct or transfer through the metal pot and into our food very easily. Nonmetals are found to the right of that zigzag line on the periodic table. All nonmetals have a number of characteristics in common. For instance, over half of them are gases instead of solids at room temperature. These guys are not malleable. They're not able to be flattened with a hammer. They're not ductile. They're not going to be able to be stretched into wires. They're not going to be shiny or metallic anymore. These guys are dull and earthy looking. They're poor conductors of thermal electricity or thermal energy, and they're poor conductors of electricity. We talked a little bit on a previous slide about the group of elements that Mendeleev did not know about because they hadn't been discovered. That's these guys right here in group 18. They're called the noble gases, and they actually have a complete set of electrons in their outermost layer. One other thing that all of these nonmetals have in common is that they have a good number of electrons in their outer layer. They might not be completely complete and full, but they're going to have far more than our metals will. Metalloids are found right along that zigzag line on the periodic table. They're the green elements here in this picture. They have about half of the characteristics of a metal and about half of the characteristics of a nonmetal. They also have about half of a complete set of electrons in their outermost layer. Interesting how those electrons, the number that there are, have a huge role in the characteristics of that element. So for instance, metalloids are good conductors of both heat and electricity. And so in that sense, they're like a metal. But unlike a metal, metalloids are shiny and they're brittle. So they're shiny, but just kind of like a metal. On the other hand, they're brittle, which means that they're not going to be able to be shaped into wires or flattened successfully with a hammer. Now each element has its very own square on the periodic table, and inside each square we can learn a lot about the elements. The first thing you'll see oftentimes is a name. Elements can be named in a variety of ways. They're sometimes named after the people that discovered them or the places that were important to their discovery. Really, whoever discovers an element gets to name it, so the names can vary quite extensively. They can also vary by country because sometimes scientific communities are in dispute about who actually discovered and got the naming rights to an element first. Chemical symbols, however, which are also on the squares in the periodic table, are going to be the same everywhere you go. They're sort of like the metric system of the periodic table. Chemical symbols are made up of 1 or 2 letters. Occasionally, a brand new element might have a 3-letter symbol instead. Regardless, the first letter is always going to be capitalized, and any letters that follow, the second or the third letter in some cases, will be lowercase. You're also going to see some numbers on each square of the periodic table. One of those numbers represents the atomic number, which we'll talk about more later on. Another one is going to always represent the atomic mass. The periodic table is organized into horizontal and vertical rows and columns. Remember that a row goes side to side and a column goes up and down. So when we're talking about these rows, those are the horizontal rows that go side to side on a periodic table, we call those rows periods. So when we move from left to right along a period, like this big undisturbed green one here, through the picture that you see on your screen, you're going to see a pattern of elemental properties. So you'll notice that we go from metals and metal-like characteristics to metalloids to nonmetals. If you envision that zigzag line that was running through our previous slides, you're going to see those same characteristics repeat if we start to slowly work our way through this blue period on the periodic table. We have our metals, then our metalloids, and our nonmetals. And if we go into this purple period here, we're going to see the same thing happen. The characteristics go from being metals to metalloids to nonmetals. These properties are going to repeat. And then we can cycle back just like the days of the week, and we can start over and over and over. That's why those are called periods. Columns, or groups, which move up and down vertically, have similar characteristics and chemical properties. So all of the elements in group 1 of the periodic table, for instance, are going to share the same properties. Same with group 2, 3, 4, 5, 6, 7, and 8. Now you'll notice that there are a whole bunch of white elements or white boxes here in this periodic table. There are so many elements that share characteristics with the elements in group 2 that they sort of got their own little space in the middle of the periodic table. These guys are actually lumped into groups 2 and 3. Sometimes we'll hear groups not called groups, but families instead. This video is going to be on my website. I would like you to watch the first 5 minutes as part of your homework for today, or you could do it tomorrow, I guess, too, if you would prefer to do that. It gives some really great history about the periodic table and about Dmitry Mendeleev, who was the guy that sort of started it all. When you're finished with that video, there is a periodic table activity that I would like you to complete for Friday. There's a lot from this section that I'd like you to try to remember. Some of this is a review of the objectives. All of it is good stuff. So you might want to pause your video now and just read through that remember box before you move on. Let me know if I can help you with anything else. Have a great day.